Hey everyone, we're going to find the radius of convergence and interval of convergence of the given series. So we're going to use the ratio test given here, and I know it's hard to see. I have these photos on my Facebook page if you ever want to save the picture. So basically we're taking the limit as n approaches infinity, and this is going to be our a sub n here. All right, so we do a sub n plus 1 divided by a sub n. And then that's going to equal the limit as n approaches infinity of the absolute value of x to the power of n plus 1 divided by 5 to the power of n plus 1 times n plus 1 to the fifth power. Now, we're dividing by a sub n, which is the same as multiplying by the reciprocal. So we're just multiplying by 5 to the power of n times n to the power of 5 divided by x to the power of n. So let's simplify this. We're going to get the limit as n approaches infinity. And looking at this, if you look at this right here, this is just going to be absolute value of x. And then when you look at this piece here, using your quotient properties of exponents, that's just going to equal 5. And then for this piece, this is going to be n divided by n plus 1 to the fifth power, because they both have the power of 5. So this is going to be absolute value of x divided by 5 times the limit as n approaches infinity. This is 1 divided by 1 plus 1 divided by n to the fifth power. So this is the absolute value of x divided by 5 times 1 to the fifth power, which equals absolute value of x divided by 5. Now, using the ratio test, for this to be convergent, we're using condition 1, and that has to be less than 1. So basically, when you cross multiply, we get the absolute value of x is less than 5. Therefore, your radius of convergence is 5. Now, to find the interval of convergence, we're going to test x equals negative 5 and x equals 5. So we're doing the, did I do this right? So we're doing the interval of convergence. But let me go over that. So when x equals negative 5, we get the series, the sum from n equals 1 to infinity of negative 1 to the nth power divided by n to the fifth power. Now this converges by the alternating series test. All right, and then we have to check for x equals 5. When x is 5, we get the convergent p series. N equals 1 to infinity, 1 divided by n to the fifth power. So for the p series, p equals 5, which is greater than 1. So it's also convergent. So for the interval of convergence, since they're both convergent, you're going to write this as the interval of convergence equals negative 5 to 5, closed intervals here. If one of these diverged, it would be the open interval, or the other one. But they're both convergent, so they can equal negative 5 and 5. Thank you. Have a nice day. Bye-bye.